Good afternoon. Thank you for joining us for our webinar, a smartEn webinar on grid integrated electric buses and trucks, which we have entitled Heavy on the Road, Easy on the Load. We will be discussing today the rollout of increasing amounts of electrified heavy-duty vehicles and how to reconcile these with the needs of the electricity system and the grid, and what advantages smart electrification can have in this sector, as we're launching a new position paper on this precise issue. My name is Thomas Neumann, Policy Manager at smartEn. I'll be leading you through today's agenda, which looks as follows. First of all, we'll have 5 minutes of brief welcome and opening remarks. Then we'll be handing over to Kai Tullius from DG Move, the European Commission, who will give us an introduction into strategic levers to integrate electric HDVs into the grid, so the Commission's policymaking perspective. We'll then have a panel with 4 very exciting real-world use cases and examples as to how heavy-duty vehicles can be integrated into the grid. And we'll have also then a Q&A with Slidos, who will be taking your questions as well. Want to make it interactive before we get to closing remarks by Jeremy Yapp, our chair of the e-mobility task force within smartEn. So briefly, house rules. There's not many. It's a pretty standard webinar, but as I've already mentioned, you can bring forward your own questions. We'd be very happy to answer and to interact with you today. But either you scan the QR code on the right, or you can use the code on the left of this slide. And if you miss it now, don't worry, it will be also displayed on some of the following slides. So you will be able, to later also ask your questions and join the Slido. So just as a quick background, why grid integrated heavy duty vehicles? We have seen in the past decades a stagnation of demand for electricity in final energy use. So starting in the 1990s at around 17%, you saw a slow but steady uptake, but especially in the past decade, we've been standing between 22 and 23%, according to numbers from our colleagues. Yeah, very sorry for that. I don't know what that was, but I got briefly kicked out. So as you see, the numbers from our colleagues at Euroelectric, stagnating demand for electricity, and we'll see that this will need to ramp up to keep up with EU energy and climate targets. So by 2030, we will need to reach already 35%, so that's 50% more in electricity demand and final energy consumption than today. And by 2050, we'll have to triple that nearly. And we see some encouraging signs that electrification is picking up. Here are some numbers from Ember, where we see that from 2023 to 24, there was an uptick in 1.2% in final electricity demand. But the question is, how much of that is actually flexible? Why does that matter? Well, we see here, we'll have to go from 3.2 million electric vehicles in 2023 to around 30 million in 2030. So we need to 10x the number of vehicles on the road. And if we just have passive electrification of demand, that will lead to more strain on the grid and massively increased cost to satisfy the peaks in grid demand. And so we need an active and flexible electrification of demand, because if we don't electrify in a flexible manner, you can see here, electric HDVs could account for up to 30% of final electricity consumption from transport, with peak power demand of around 20 gigawatts. So that could lead to very significant cost. And we can see here already today, a quarter of average electricity costs is due to network cost, and this might increase significantly. We see the ASER numbers here on the right. There could be a 60% increase between 2022 and 2050. So with grid integration of heavy-duty vehicles, with peak shaving and smart charging demand response, we can mitigate some of these upcoming costs. And so in the end, we have top 3 benefits of flex electric HDVs. We've already talked about the grid, being able to shave some of those peaks, while also reducing the total cost of ownership for transport operators. So you could also profit if you run a fleet of heavy-duty vehicles in terms of the cost and the cost savings. And then lastly, we would have a cost-effective integration of variable renewable energy. So it would also have to help the climate and help decarbonization along. And with that, I hand over to Kai Tullius from DG Move for some opening remarks. Kai is at DG Move. I've worked with him inter alia on the AFIR, the key charging file at the European level, where he is the responsible officer. But he's also been at DG Enner, so he has an understanding as well of the kind of grid implications, and he's worked also before joining Commission as a consultant advising public transport companies on dispatching. So he knows also the fleet operator perspective, and therefore I think he's the perfect person to give us some opening remarks. Kai, we're very happy to have you here, and the floor is yours.
Thank you, Thomas. Happy to be here. Thomas already gave you a bit of an overview here about the importance of electrification, about the overall increase in demand, which will more than double until 2050, and the urgent need for the transport sector to decarbonize here to meet our climate neutrality goals by 2050. Transport basically has to reduce its emission by 90%, and basically road transport has to fully decarbonize by 2050. And this goes for both, that for cars and vans, as well as for heavy-duty vehicles. Today's focus is just on heavy-duty vehicles, so just so we are clear what we are talking about here. Heavy-duty vehicles are all vehicles above 3.5 tons. Those are basically all lorries, be it the small urban delivery lorry, but up to the 40 tons with a trailer you see on motorways. Buses and coaches and heavy machinery vehicles. So that's what you usually see on construction sites. There are around 7.2 million heavy-duty vehicles in the EU, and 6.5 of them are actually lorries. So it's really largely trucks we are talking about here. And those have to decarbonize. We have legislation in place, mostly the CO2 emission performance standards, that basically mandate that the emissions need to reduce by 45% by 2030, 65% by 2035, and 90% by 2040. For buses, the provisions are stricter. 90% of all new buses need to be zero emission by 2030 and all by 2035. We are basically starting not quite from zero, but we are really at the beginning. We have today around 13,000 electric lorries and 20,000 electric buses on our roads. And by 2030, in order to meet the first step of the CO2 standards, we will need around 400,000 to 600,000 zero emission HDVs by 2030. And those numbers will then steadily increase until the total fleet will be zero emission at the latest by 2050. To be accurate here, the standards talk about zero emission vehicles, not about electric vehicles. So that can also include other technologies such as hydrogen. But at least for the initial stage, we actually expect most of it coming from electric vehicles, as the other technologies are not quite as advanced. So we do at EU level have the targets on the vehicle manufacturers. What we do not have, apart from the Clean Vehicles Directive, is a really pull factor on the demand side. We don't have mandates for operators to buy zero emission trucks. And we basically see for the time being two main obstacles here. The first one is the total cost of ownership. The purchase costs are still very high. Here, smart charging, bidirectional charging comes in because it can actually reduce the operation costs of electric trucks. The second point is really the availability of recharging infrastructure. Not so much because nobody wants to invest in them, because they can actually be a quite lucrative business by offering publicly accessible recharging. It is more the problems to actually get the grid access for these larger power demanding installations. So a huge bus depot with 200 buses may need around 10 megawatt connection. The same goes for larger recharging pools along the highways. And it is extremely difficult for depot operators, but also for those who want to install publicly accessible recharging, to actually get the grid connection. So there are lengthy procedures. Very often, basically, there's no capacity in the grid at all. So we really need to address this issue also with a lot of force, because, well, at the end of the day, if you can't get an electricity connection in the first place, you can also not do bidirectional charging. But let's assume we overcome the grid connection issues, HDVs do have a lot of potential for flexibility. Simply also because of the large battery size. But there are other factors as well. I mean, they're charging already in DC. So when you feed electricity back to the grid, it doesn't have to be converted into AC. It's a problem we have for slow charging for cars. HDVs follow strict planned schedules, including the schedules for charging. So this means that it is very well known in advance at what time which vehicle can provide how much flexibility. So this makes bidding into the electricity market rather straightforward. And there's the volume issue. A single bus depot of, let's say, 200 buses, each of them with a battery of 500 kilowatt, has an aggregated battery capacity of 100 megawatt. To get the same capacity just from cars, one would need to aggregate at least 2,000 cars. But those most likely individually. So there's also a lot of admin burden taken away from actually aggregating loads of very, very small individual loads, but just basically offering flexibility from a full depot. I think what becomes clear, flexibility from HDVs and from the vehicle sector in general is of importance, and we are actually trying to enable that at EU level through various measures. Through AFIR, but also the Renewables Energy Directive and the EPBD, we mandate smart charging capabilities for all public and private recharging points. With the delegated act under AFIR, we are now planning to mandate standard ISO 15118-20 on all recharging points as of 2027. So that means we would actually have an interoperable standard for bidirectional charging, making it also much, much easier from a technical point of view. And through the Sustainable Transport Forum, and together also with the colleagues from DG Energy, with the Data for Energy group, we are actually looking now also in defining the exact data points that need to be exchanged to actually make bidirectional charging a reality. And you may be aware that the Commission will also adopt the Automotive Action Plan in early March. And, well, we don't know the content yet, but that may also address in one way or another bidirectional charging. So I've been addressed all the potential and the enabling framework that we have in place, but I would also like to talk a little bit about the challenges, which I think also in smartEn's paper are not really highlighted very much, but I think they are there, and I think we also have to be aware of them and address them appropriately. The first one, I think it's a bit of an understanding issue maybe, but when you look at or talk to energy stakeholders, they still often refer to vehicles as batteries on wheels. And I fully understand where they are coming from. They actually see the flexibility potential. But those who actually own the vehicles would never refer to their truck or to the bus as a battery on wheels. For them, it is an asset. The operator invests into the asset to generate income from transporting goods or passengers, and that very often on a scheduled service. That basically means the battery must foremost serve the transport needs of the vehicles and not the electricity, the flexibility needs of the system operators. And that also means that basically only in the scheduled times can the vehicle offer the flexibility to the electricity system. And these charging times are limited. When you look at a typical bus operation, for example, a bus leaves the depot fully charged, and it has to be fully charged at 6 o'clock in the morning and might come back at 8 in the evening empty, which actually leaves them a 10-hour break charging time when it actually has to be fully charged until it goes out the next morning at 6 a.m. again. Situation is actually pretty similar for lorries who are not just operating in the morning. Most lorries are operating in 2 shifts also during the whole day. So basically, the time frame for charging, and this is different for cars because they are basically parked 23 hours, but buses, lorries, they are operating, and this is their whole purpose. So the charging time is actually limited. On top, when we actually want to do peak shaving, basically in the morning and in the evening peaks, the vehicles are actually on the road and cannot provide actually this flexibility here by actually feeding electricity back to the grid. And then I think there's also another issue that one has to consider when actually designing the network connection for a depot, for example. I said before, buses need to leave fully charged in the morning, and they have a time frame of, let's say, 10 hours. But what happens if they provide flexibility within this 10 hours? Well, the charging time is basically effectively reduced. And they cannot charge longer because they have to leave. So if you reduce the charging time, you actually need to increase the speed of charging, which basically means you have to oversize the recharging points, and you have to oversize the overall grid connection to the depot, actually then also adding certain additional costs. That might still be good from an overall system perspective, but first of all, it is also an additional cost to provide a new network connection for a depot. So to conclude, there's certainly a lot of potential for smart and bidirectional charging, also for heavy-duty vehicles, and I think European legislation provides a good enabling framework already for it, and we are working to actually further improve it. But I think there are also operational challenges, and what I really hope from today's meeting is that I learn a little bit more on how you actually addressed those operational challenges in your real life operations. Thanks a lot.
Thank you, Kai. Thanks, Kai, for your remarks. Yeah, probably a very fair assessment. Thanks for pointing out to us some of the advantages and opportunities we have on the HDV side, some of the challenges still, like grid connections, but also predictable driving patterns, big batteries, which is why they offer themselves. We appreciate also the efforts that you mentioned in the STF and D4E subgroups on solving some of the remaining challenges, but we also, of course, take on board very well your points on operating patterns, operator needs. Hopefully we'll get to discuss in the panel a bit the different use cases and the different transport needs. And in the end, indeed, this is about marrying the needs of the energy system and, of course, also of the transport system and the transport operators. So, yeah, let's dive into the panel and hopefully shed some more light on this. And first, I'll pass the floor for some opening presentations to our 4 speakers. And first up, we have Laura Casolo Ginelli, who is R&D Program Manager at Hive Power. She has over 8 years of expertise in technology, marketing, and product development in the energy sector, working on solutions like smart EV charging. Laura, thanks for joining us. Very much looking forward to your opening remarks. The floor is yours.
Thanks a lot, Thomas. And hello, everyone. So who is Hive Power? So Hive Power is specialized in optimizing energy use through a software solution, which is called Flexo, our flexibility orchestrator software. What's the main objective in our algorithm? It's really to charge at the best time, at the best price, and with a seamless UX. And this seamless UX is really important because we don't want to interfere with our customer behavior. And we see this already when it comes to fleet of cars, but especially when it comes also to the strict schedule when it comes to HDVs. So we conducted a project with Iveco to explore how smart charging could reduce the total cost of ownership of electric heavy-duty vehicles, such as the electric buses. So the project began with a simulation using Flexo, the flexibility orchestration software, which analyzed the energy needs for each vehicle and optimized the charging times. So those simulations were conducted in different markets in order to test the system under varying electricity pricing models, but also different regulatory environments. So one of the main objectives of smart charging and flexibility is to allow fleet managers to reduce the charging cost and offer additional services, such as demand response and grid balancing, which generates extra revenues for the fleets. So these opportunities makes the transition to electric fleets even more attractive, as they help offset the high initial purchase cost, which is still one of the most prominent entry barrier. The results that we demonstrated with Iveco were really compelling. By shifting charging schedules with B1G technology, the project saw saving up to 35%. That could really go up then to 57% when vehicle to grid came into place. So with increased savings. So what's most important is that those savings were achieved without requiring any changes in the daily operations or behavior of fleet managers. And this demonstrates that smart charging can significantly reduce the TCO from the electric heavy-duty vehicles and makes the adoption of electric fleet even more affordable. So looking ahead in our project with Iveco, we aim to scale those solutions. So coming from the simulation phase to come to the real world scenarios, but also to extend from HDVs to LDVs, so the light duty vehicles, like the e-dailies. And we aim to test with scenarios up to 100 vehicles in the sites. And the goal is to validate the scalability of the solution and to test and showcase the capabilities of Flexo to provide grid services like frequency control reserve, enhancing grid stability while continuing to reduce the cost from always looking at the TCO perspective. So what also important is that we are collaborating with the business stakeholders to develop revenue sharing models that will make the solution even more financially attractive for fleet operators. So it's not only the innovation that comes when we have the energy optimization with Flexo, but it's also about business model innovation, because we want to make sure that those benefits coming from the energy market access really comes to the fleet operators as a value. So in conclusion, we can confirm that flexibility, so taking into account smart charging, but also the vehicle to grid technologies, have the potential to revolutionize the electrification of heavy-duty fleets by reducing the charging costs, supporting the grid integration, and creating new revenue streams. So these technologies are really playing a critical role in accelerating to the transition to sustainable and effective cost for electric fleets.
Thanks, Laura. Thanks for providing this very, user-focused perspective, fleet operator-focused perspective, showing how assets can be used in new ways rather than just as grid assets, and how it's important to make this also user-friendly. Next on our panel, we have Benjamin Kroupa, who is Senior Advisor for Political Affairs at TenneT, Transmission System Operator. Mr. Kroupa has 8 years of experience in EU energy and climate policy in the European Parliament for the Zentralverband countries, now most recently at TenneT. So, Benjamin, thank you so much for joining us, and the floor is yours to present your views.
Yes, thank you very much, Thomas. Good morning, everybody. So yes, I'm representing TenneT. We are a transmission system operator. We are operating the grids in the Netherlands and also in large parts of Germany. So I'm going to present the case of Spirit E. That means e-trucks for flex. So let me point out what is Spirit E. First of all, so it's basically an innovation project, maybe a research and innovation project. And the idea is to make electric trucks available not just as users, but also as active players in the energy system. We achieve that by deploying bidirectional charging infrastructure and technologies, also to take care that the infrastructure is shared and also to test it in a real world environment. If you look at the motivation of Spirit E, so basically you have the overarching commitment by the international community, which is the Paris Agreement. So we would like to limit the global warming below 2 degrees Celsius, but also on the national level, we have legally binding climate neutrality targets by 2045, at least for Germany, but also for the Netherlands, to 50% reduction of the transport-related CO2 emissions by 2030 in Germany. As we have heard already by Kai, there is a reduction target on the EU level as well. That is 90% less CO2 emissions from heavy-duty vehicles by 2040. And if you look at the commercial vehicles, or in general, experts agree that battery electric trucks, they really have a high potential and maybe even the highest potential for reducing these emissions. And as a TSO, as a transmission system operator, for us, it's even more attractive because we can now integrate these electric trucks as a source of flexibility. So there's a huge potential for flexibility. If we look at the next slide, what are the main activities we do within Spirit E? So first of all, we have 3 core innovations. That is to create the shared charging infrastructure. It's about reservation. That's basically the management. When do they charge? How do you manage that by electronic or digital platforms? And also, what I said already, to provide flexibility to the grid. So we can provide system services with this. That means we need to integrate bidirectional DC chargers at logistic sites on a larger scale. With doing that, we are demonstrating that these core innovations mentioned before are working under real world conditions. We also learned about how to integrate them and what follows from that. We can then also dispatch. It's also interesting that these logistic sites then can integrate this into overall site energy management. So energy management of the logistical side. Once again, for us as a TSO, in particular, if we talk about ancillary services or system services, we are looking very much at redispatch or congestion management. That means we need to reduce the congestion in our lines to have more grid stability and also to reduce costs. We make the grid more efficient with that. What we are also looking at within this project is the economic potential. It was also said earlier that, the logistic providers, they can use this not only as a transport means, not only as their assets, but also as a cost reduction potential. So last but not least, I would like to call for action, because what we need to achieve now is to really scale this up. To scale up electric logistics, we need more industry collaboration, and this is basically exactly what we are doing with Spirit E, and we are proving that it works. So very important now for us to take the next steps now and to bring this to scale, to provide more flexibility to the market.
Thanks, Benjamin, for this brief overview and also for your call for action, which I think everyone here agrees with. Looking forward to hearing more on your experiences during our discussion. Next up, we have Philipp Leitner. Philipp is Senior Business Development Manager at the Mobility House. He has a background in automotive consulting and EV engineering, so he understands the technical side quite well, and leads now projects and partnerships on the grid integration of commercial fleets, for example, with the public transport authorities in Amsterdam. So he can give us some practical insights. Philipp, thanks for joining us, and the floor is yours.
Thanks for the intro, Thomas. So I was jumping one ahead. So there we are. That's my slide. So we at the Mobility House, as Thomas said, we are providing services and software to help users integrate their fleet, their vehicles into the grid. And for today's topic, I brought one very simple slide, I think, but I think it kind of symbolizes a lot of what we are already doing in the real world. So if you look at the left-hand side, we have the Allianz Arena in Munich, home of the FC Bayern München, and they use about 8.5 gigawatt hours per year. And if you look to the right, we're looking at the heavy-duty fleet, namely the one I'm talking about today in Amsterdam. And for around 100 electric buses, we need around 9 gigawatt hours per year, which can obviously deviate slightly up and down. But the main point here is really you realize that in the future, a lot of fleet operators will practically own a whole football stadium. So imagine for a second owning a football stadium. What would you do? How would you approach it? Well, first of all, would need to talk to the grid operators, right? Like, I want to build this huge stadium. How do I integrate it? I'm going to need a lot of power to do this. And also, on the second hand, you would think about energy, right? I'm needing this huge amount of energy to power this arena for the games, for any other events that are happening in there. The main difference here, though, is, and that's why I also very much like the opening remarks from Kai, is that the Allianz Arena in Munich, they cannot decide when to turn off the lights, or they don't have any flexibility, right? Nobody would be happy if they would just turn off the lights during a game. Big advantage for the fleets, obviously, is here that you have the full control about how and when exactly to charge the fleet and the vehicles. You have a starting and an end point when the vehicles come in and they need to get out at a certain point. But you know your starting and your end mark. And in between that, you have flexibility. And you can use this flexibility in order to really open up another revenue stream, we heard it before, to have a positive impact on your TCOs. And also referring back to the opening remarks, when we think about how you would own a football arena, well, the first point would be you have to be operational. Like I said, you can't turn off the light just because it's cheaper. If you would turn off the light, the players wouldn't be happy about that. But at the same time, if you operate a football stadium, it would be your obligation to minimize your energy costs as much as you can by all the means and possibilities that you have. And we did exactly that, or we are doing exactly that at the Mobility House. We are providing players with the software, the services to integrate their vehicles, their assets into the grid without impacting their operation whatsoever. We are doing this, and we're talking about here real-world examples, so we are far behind like a simulation or a tryout stage. We are doing this not for the Allianz Arena in Munich, but for the Ajax Arena in Amsterdam. We integrated this arena into the grid and providing different services during games, during concerts. We are also doing it for the case on the right-hand side for a public transport operator in the area of Amsterdam, where we are integrating their vehicles with different services into the grid, have them benefit from the possibility to smart charge their vehicle according to grid to energy market needs. And additionally, we also, as the Mobility House, released together with Renault the first V2G commercially available product as of today. So Renault owners in France, they can charge as of now if they own a Renault and have the bidirectional charger for zero cost for their driving. And I think this is a great example that we are not at a stage where we're talking about this vehicle grid integration, about some theoretical construct that might work or is like a topic for the future, but it's actually happening right now. We've proven that it's possible in a commercial setup. And of course, it's something to discover for each fleet individually, because it's not a commodity product as of now, but we certainly have the proof that it's totally doable and it's integratable in your fleet, wherever you are in your journey in terms of electrification. Thank you.
Thank you, Philipp, for this breakdown of these exciting next steps, but also showing us a bit the dimensions that we're dealing with this very very interesting slide, I think, and also some of the limitations and chances and how to operate within the limitations of operational patterns and how to make the most out of these assets without impacting the way that they need to be run. So thank you very much. Before we move on to our last speaker, I would remind you to please leave your questions in the Slido. If you have any questions, we'd be very happy to answer them. And with that, I move on to Quentin Maitre, who is Chief Marketing Strategy and Development Officer at DREEV, which is part of the EDF group, which indeed he was part of creating this sub-entity. He's an energy engineer and economist by background, has long studied the potential of electric vehicles and how they could become a source of flexibility for the power system, and has worked on some large-scale V1G and V2G projects in France, and continues to work on some of the cutting-edge major European V2G projects nowadays. So again, Quentin, happy to hear your insights, and the floor is yours.
Hello, everyone. So DREEV, we are a technical aggregator. We do the aggregation and optimization of electric vehicles, both in V1G and V2G. V2G for us is at a pre-commercial stage, but V1G is really live. It's commercial in France, especially with fleets. Today we manage around 100 megawatts of fleet charging flexibility. It includes, let's say, passenger cars charging at companies, LCVs such as Amazon delivery vans, electric buses, and trucks. Our service, for example, has been live for the electric buses in Paris. We have hundreds of electric buses running with our services every night, playing with the flexibility on the energy market, and it's working perfectly. But today, as we already talked about electric buses, I will more focus on e-trucks. E-trucks, what is interesting is that the sector is really rising, more and more e-trucks on the road. And for this category of customers, the costs of electricity is completely key. The logistic companies, they have been used to buy the cheapest fuel, because really the fuel costs is key for their business. Otherwise, they are not competitive. And so flexibility is a big way of a big lever to minimize their electricity costs and so their fuel costs, and accelerate the electrification. You can see the operation of what we do every night on the little picture at the bottom. So you can see in orange the natural charging load curve. This is the Parisian e-buses, and in blue the let's say V1G load curve. So we try to focus the energy of the depots at the best hours on the energy markets. And so, as Kai mentioned in the introduction, we need some power. We need to maybe oversize a bit the infrastructure to be able to create this peak demand at the best hours and capture the best electricity prices. And so that's why, if we move to the next slide, but for the e-trucks, we really need, and that's what we did in the last month with all the logisticians accelerating their transition to electric trucks. We help them to correctly dimension their e-truck depot. So we are talking here on the depot where the trucks will charge during long periods, not on the highways, etc. Because it's crucial to enable flexibility and secure the best kilowatt-hour price. And you can see on the graph, we have conducted a study to see the difference of charging costs depending on the power you install. So this was for, let's say, a big e-truck driving a lot, 500 kilometer per day. So quite a lot of energy to charge every night. And we did two scenarios. One scenario with 75 kilowatt charger, and one scenario with 150 kilowatt charger, and with V1G and without V1G. So at year zero, obviously, if you install less power, it is less expensive. but you see the red line is growing faster than the other. Your costs are growing faster because you can't really optimize the electricity costs by doing flexibility. And so what we recommended for this customer in particular was maybe to oversize a bit its installation at the beginning. So on year 0, you can see the cost is higher, but very rapidly, because of the flexibility we can provide, you can capture better electricity prices on the market. And so your charging costs starting 3 or 4 years, it's better than the other scenarios. So really here you can see the flexibility. Basically we have, in this example, by shifting to a 7 kilowatt charger to a 150 kilowatt charger with V1G, you can save 42% on your variable electricity costs. That's huge. And you can see how flexibility can minimize the charging costs of these trucks and in fact accelerate the transition to electric trucks, because the customer where we did this kind of study, this study we did it for a big logistic company in France, and thanks to the kilowatt hour price we made them because of flexibility, they said, okay, that's very cheap, and so I will be able to order new electric trucks, and they just order 300 new electric trucks. So it really helps to accelerate the electrification concretely.
Thank you very much, Quentin, for your info presentation, also highlighting the perspective not only for buses, but indeed also for trucks, which I guess are at a slightly earlier stage in terms of market uptake, but also showing what kind of potential we could unlock there. Given the advanced time, we'll now do, I guess, 1 or 2 questions per speaker. Then 1, 2 questions from the Slido. Feel free to still leave your questions now and then move to the closing remarks. So in terms of follow-up questions, maybe let's start with you, Philipp. From an energy supplier grid operator perspective, what are the biggest challenges in scaling vehicle and grid integration? And what role can grid operators play in this context, actually?
Yeah, great question. So I think the first thing to realize is that we're still talking about a very innovative topic. So it's really about having the commitment and also seeing the necessity to invest in such an innovative topic. I think that's really a challenge that you have to understand and you have to be willing to make. And then secondly is that there is no one size fits all. I think it's very clear to see that we are talking about a topic that has no standardized approach, that has no standardized technology stack that you just can use at your behalf. So it's really about starting out and understanding the complexity on your side, but then definitely be brave enough to start small. I think we talked about a lot of the word flexibility was used a lot, and I think everybody understood that for flexibility you can receive value, but I think it's a really key here to understand that the value that you get from your flexibility is not the same all the time. It changes by the service that can be provided for your flexibility. For example, we've seen the optimization on the day ahead market, which is the first step to integrate into energy markets. Second step could be integration into the intraday energy markets, which offers much more potential. So there are different values that you can attach to your flexibility. And going back to also the opening remarks, I think it's key to really look at the flexibility and try to gain the maximum value out of that, because you, as I said, you will have to invest and you will have to make this investment. So you want to have the most, the most revenue for the flexibility you're providing. And in terms of the utilities and the grid operators, I think it's fairly simple in a way that obviously they should facilitate this market participation, right? They have to offer the right schemes, they have to offer the right collaborative approach here. Since I think it's not or it shouldn't be at this stage a sole buyer-seller situation. but it should be really a collaborative approach where we've seen the two views, right? Like the grid operators, they view it as batteries on wheels, but for the operators, these are assets. So it's about like getting together and making a win-win situation essentially out of it, instead of thinking, oh, I have flexibility, I buy it, but really approach it in a collaborative way.
Yeah, that collaboration will definitely be key if we want to make that a success. So I need to thank you. Maybe staying a bit at the grid perspective, grid stability perspective, but moving on into the near future and looking at bidirectional charging. Benjamin, looking at bidirectional charging of e-trucks and buses, what effects do you see for grid stability from TenneT side once we start using buses and trucks as these batteries on wheels?
Yeah, thank you for the question. So maybe first of all, one opening remark. So what we had in the past is an energy-only market. So we had centralized generation of power, and this is now really a systematic change. We are not just substituting the energy carrier, but we are really changing the system and adapt it to renewable energy sources. So coming back then to your question, we see there several positive effects coming from the integration of e-trucks in terms of grid stability and how to operate the grid that is then reflecting actually today's needs when we have more and more renewable energy sources. We need these batteries to stabilize the grid and to integrate more flexibility into the system when there is the so-called Dunkelflaute, we say in German. That means when there is no sun and there is no wind. We need to flatten the curve when there is too much energy, or to release power when there is too little energy. And there, e-trucks have a great potential to stabilize this behavior. It is for us like a balancing resource to also have then the frequency of the grid in a very stable manner. And I think I said it already in my slides. There's also the aspect of providing redispatch services. That is so basically congestion management. This is particularly important nowadays because in Germany, as you know, we have conventional power plants phasing out. So we have the phase out of coal-fired power plants, and also we have the phase out of nuclear power plants. So there is a great need to really have enough energy, and especially in the southern parts of Germany, we can now see already that there is not enough generation power available in the upcoming years. We had the so-called power plant strategy in Germany, which more or less failed because the Commission was not so much convinced that we can provide H2-ready power plants. And that brings us then to the batteries of these e-trucks. Yeah? As I said, so flattening the load curve is for us extremely attractive, or this is what attracts us to integrate these e-trucks. And then if you look at the broader picture, so the new guardrail of the European Commission is to reduce system costs, or let's say to increase European competitiveness. That's the Draghi report. So we have three core pillars. That is strategic autonomy, strengthening the internal energy market, and bring down costs. So this is where, from our point of view, as a TSO, is the strategic outlook. And this is also where we think that in terms of grid stability and reducing costs, e-trucks are a major provider in the future. And just to give you a figure, so for redispatch and congestion management, we paid 3.2 in 2023. So these costs are basically burned money. So we just buy then the service from mainly from gas-fired power plants. And it would be much better if we, first of all, invest these costs into more grids, but also if we really tap into the great potential of flexibility that comes from e-trucks.
Thank you very much. Yeah, indeed, great potential, and maybe moving on from the systematic perspective and the great potential on that side. Laura, you talked about the user perspective in your opening remarks, and you also showed these two very interesting graphs on V1G versus V2G and what the different benefits would be. So what role do you actually see for V2G for users, and how does that compare to V1G smart charging in the way that it can offer benefits to fleet managers?
Yeah, thanks, Thomas. Really interesting question, because it really brings together the two sides here. From one side, the technological perspective, and from the other side, the user perspective, and both are equally important. So looking at V2G, of course, looking at the results of the simulations and all the pilots and that we're running, the potential is huge there. And also, like, if we look at different markets, we always see that the potential for savings for V2G, it's really like stacking upon the potential of V1G. But I would say, since we are waiting for V2G technology also to establish, and also for all the standards in the industry and from the grid perspective to be harmonized also across the markets, I would like to stress this with V1G technologies, actually we can already get a lot of value from the energy markets. And leveraging the aggregation of vehicles, whether it comes from B2C or B2B perspective, we can aggregate the vehicles in virtual power plants. We can trade in the energy markets even without waiting for V2G. So with V1G already, we can tap into this value potential, and we can expand furthermore. And looking from the user perspective, I think it's really important then to name an element of trust. That is something that is quite important in this moment, because of course, as Philipp said, we are really in innovation stage. So we're playing with in an environment where the rules are not all settled, but we need to gain the trust of our customers. So whether it is the single B2C user with the simple patterns of the day-to-day use, but looking at the fleets with HDVs, which have really strict schedule, we need to make sure that we are not violating this trust. And the technology that we have comes really to optimize this also from the user perspective. So taking into account all the energy needs of the vehicles, of the drivers or the fleet managers, to make sure that we can tap into the energy markets in the right way, and to gradually stack all the values coming V1G, V2G, and then playing with day ahead, with TSO and DSO services along the way.
Perfect. Thank you very much. Well, last question before we move on to the Slido, because I see that we're running short on time. Maybe moving on to different use cases, because Kai already talked about which use cases might offer themselves to smart charging and grid integration, and which less. So as we move to V2G, Quentin, do you see the same use cases for V1G and V2G? Are there some that offer themselves more, and why? Yeah, happy to hear your views on that one.
Yeah, so no, it won't be the same use cases, not always the same use cases between V1G and V2G, because we won't change the mobility, and we don't want to change the mobility and the pattern of usage of our customers. The goal of this kind of service is to be invisible for the operator. So we are going to select the right use cases for each service. In V2G, you really need to have long duration parking more than V1G, because you need to re-inject and then reconsume electricity and be ready when the logistic company or the e-bus operator needs its vehicle. So for instance, if we are talking about e-buses for a city like Paris is very, very relevant for V1G, because the buses are parked from 9 p.m. to 6 a.m. So we have the time to do V1G, but it won't be relevant for V2G. There is not enough time or power for this use case. But talking about buses, maybe school buses, we are exploring V2G for school buses because school buses, they are basically used 3 hours in the morning, 3 hours in the evening, and the rest of the time they do nothing. So school buses would be a better use case for V2G than city buses. Another very cool use case for V2G when talking about HDVs is garbage trucks, because garbage trucks, from what we have seen, it's used in the morning, and basically the afternoon and the night they are not used. So perfect to do some storage during the day to capture negative prices of solar energy during the afternoon, to help on the evening peak, and then to recharge during the night and to be ready the next morning.
Perfect. Thank you very much. Interesting reflections on how use cases might differ. I'm looking at the time, but also at the Slido. Let's take maybe the top 2 questions from the audience before we close. So very, very briefly. Top question is from Anonymous. It was mentioned that overcoming connection issues is the first step on integrating HDV and LDV into the grid. What do you think that should be done at regulatory level to overcome these issues? Is there anyone that would like to have a step at that one? If not, I'm going to pick one.
Maybe I can, as a TSO. It's indeed true. So we need to connect a lot of customers. We have a long connection queue, indeed. So a lot of requests, not only, also for batteries, for example, and other customers. So that is really our priority. So deploy grids as fast as possible. This is really the priority. And I'm very thankful that the Commission really understood that. We have the Renewable Energy Directive, for example. There is an acceleration provision already in there. We use that a lot to accelerate grid projects. And but still, there's so much to do. So we need to clarify how to finance that. There is a huge investment pipeline on the table now, and we need all the support we can have from the policymakers. We are working on this every day. Unfortunately, grid projects, they have a very long project pipeline, so it will not be solved by tomorrow, but we are working on it, and so the faster, the better.
Thomas, you're on mute.
Thank you so much. That is a valuable hint. Okay, very last question from the audience comes back to Kai's opening remarks. Is there any concerns that HDVs will not be able to support grid stability due to their unavailability during the day from 6 a.m. to 10 p.m. when it is needed? So how to marry again the operational patterns with the needs of the energy system? So don't know, maybe Quentin, can you speak on this?
It depends on the use cases, because I have a customer, for instance, which is doing some cleaning for all the luxury hotel in Paris, and basically their pattern is to leave the depot at 10 p.m. and to come back at 6 a.m. And so during all the day, from 6 to 10, they are on their charger, and we can play with their charge. So by having many use cases with many usage pattern, we can create this kind of virtual battery equivalent to a standard battery, and help on different services for grid.
Perfect. Yeah, we take away HDV is kind of a broad field, a broad church with lots of different use cases. So we'll have to go probably also case by case as we implement this, and it's hard to make blanket statements. With that, we want to be respectful of your time. So if you have any questions left, we know we couldn't go through all of them in the Slido. Feel free to send them to us or our panelists, and we'll follow up with you. And I'll hand over to our e-mobility task force chair, Jeremy, to wrap up today's discussions.
Thank you very much, Thomas, and thank you very much to all the speakers. That was really fantastic deep dive into some of the aspects, some of the challenges and opportunities with electrifying heavy-duty vehicles. Just to sum up for me, those of you who know me won't be surprised. I want to emphasize the positives. So I would just say, in common with electrification generally, what we see here is a challenge or a benefit. And these things are political, regulatory, commercial, and behavioral decisions. So we can have increased demand, we can have higher peaks, 20 gigawatts of additional demand if unmanaged, more demands on transmission and distribution infrastructure, more demand on generation, and a mismatch between generation and demand. Or heavy-duty vehicle electrification can be a friend to the grid, and we've seen some really great ways how that can happen. So if managed flexibly in response to generation intermittency, but the only way for this to happen is by the integration of these vehicles into the energy system. Some inspiring and useful case studies here. I don't have time to run through them and give you all my responses to them, but just to say, CapEx and OpEx considerations really jumped out at me. And I really loved what Laura was saying about V1G and V2G value as not interfering with each other. We shouldn't be waiting for V2G use cases. We should be getting on with V1G. It's just useful, I think, to remember that HDVs are often used more predictably than other vehicles, especially more predictably than private vehicles. So they lend themselves to some more specialized use cases, these school buses and garbage trucks that were mentioned. It was great to hear Benjamin speak of the Dunkelflaute, and I hope my German pronunciation of that is okay. And the idea that e-trucks replacing gas turbines, that's very exciting times. I know we're short on time, so I'm just going to leave you with two thoughts. Firstly, there are some potential solutions outlined here with a huge potential, for example, for V2G in different, like multiple different markets. So we're talking about stackability. And when we talk about the innovative approaches to infrastructure development and build and integrating the integration of flex dispatching on spot markets and charge point planning and site energy management and so on, I keep coming back to what Quentin was talking about appropriate technology. So there's still so much need for research and innovation and mistakes and false starts and happy accidents, but there is going to be this tension between the need for innovation and experimentation, but also the need for rapid scaling. And I think that's something that we are going to have to navigate quite cleverly. It does feel unstoppable. So my second point is just, this feels unstoppable, but we need to focus on near-term profitability to support the rapid and sustained scaling of the smart management solutions. So there is a baseline issue. Our solutions, I think, need to be better than business as usual. They can't just be better than a badly managed transition. They have to make a better charging or refueling experience now in the short term. We have to make electrification work as a cheaper OpEx now. We have to identify additional use cases, more paths to revenue, diversification of the revenue scheme, and Philipp gave us some really inspiring examples there. So if we can demonstrate that electricity is an appropriate and scalable approach to transport, that it's the best solution, then I think this is going to be a really, really exciting journey. So please use this document. Please read it. Please share it with your clients, share it with your colleagues, and please let's all continually strive to do as well as, even better than, the solutions described here. I pass back to Thomas. Thank you very much for your time. Thanks, Thomas.
Thank you very much, Jeremy, and indeed thanks to all our panelists and also to you as an audience. Before we close, a very, very quick pointer. We'll be at the smartEn in Munich in May. We're partnering with them on a special exhibit on bidirectional charging at the smartEn Europe. So smartEn will be involved there. There will be live demos, expert lectures, and it will be a nice forum for exchange. So if any of you are there in Munich on 7th to 9th May, then we will look forward to exchanging with you there and seeing you there. And with that, I thank you for attending today. I thank again our panel. I thank you, Kai, for giving us some insights from the regulatory side from the Commission. And yeah, we hope to see you for future webinars and hope you took something away from today. Thank you very much.